Hello everyone, welcome to PUC Physics Explained channel. In this fifth session of the first year PUC Physics Chapter 1, Units and Measurements, that is, dimensions of physical quantities I am going to take. What are the dimensions of physical quantities? If the physical quantities are represented by their nature, then we are going to call those are the their dimensions. The dimensions are required to represent the nature of the physical quantities. And firstly, we'll take the dimensions of the seven fundamental quantities, and later the other quantities are represented by the dimensions of the seven fundamental or base physical quantities. Then kindly subscribe to PUC Physics Explained channel. If you have already subscribed, kindly share and comment. Here, I am going to take the explanation of these dimensions of the physical quantities along with the material, study material, what is required for the preparation. You can have the ready referral material and prepare well from this one. First, the dimensions of physical quantities. The nature of a physical quantity is described by its dimensions. The nature of that physical quantity is represented by dimensions. All the physical quantities, all the physical quantities represented by derived units and can be expressed in terms of some combination of dimensions of seven fundamental or base quantities. As I mentioned, okay, here the initially the seven fundamental quantities dimensions we are going to take, and other fundamental physical quantities what are there, their dimensions we are going to take the combination of dimensions of seven fundamental or base quantities. We shall call these base quantities as the seven dimensions of the physical world. The seven fundamental quantities or base quantities dimensions what are there, those we are going to call as a seven dimensions of physical world, which are presented with square brackets. Whenever we represent any physical quantity in terms of the dimensions, we are going to represent in terms of the square bracket. And thus, the dimensional symbol of length is within the square bracket L, for the mass within the square bracket M, for time within the square bracket T, electric current within the square bracket A, thermodynamic temperature within the square bracket K, luminous intensity within the square bracket CD, and amount of substance within the square bracket wall. The dimensions of a physical quantity are the powers of or exponents to which base quantities are raised to represent that quantity. The base quantity or fundamental quantities what we have taken, and their dimensions we are going to use for representation of other physical quantities, and there the powers or exponents we are going to take, and by which the base quantities how these are raised to represent that quantity. That means their powers, it may 1 2 3 like that, or negative also we are going to take to represent. Note that using square brackets around a quantity means that we are dealing with the dimensions of the quantity. If you use any symbol within the square bracket of the physical quantity, then we are going to say that we are dealing with the dimensions of that quantity. In mechanics, all the physical quantities can be written in terms of the dimensions L, M, and T. That is the length, mass, and time. In the mechanics, we are going to use these three dimensions. For example, the volume occupied by an object is expressed as product of length, breadth, and height. If you take any substance, there its length, breadth, and height, what is there? It gives the volume of that substance within the container. There are three lengths. If the three lengths all are same, we are going to take the three lengths. Hence, the dimensions of volume are length, length, length multiplication. Within the square bracket we have taken, those are represented in terms of the dimensions. Okay, then that becomes a within the square bracket L cube. Then that can be written as within the square bracket L cube. This is the dimension of volume. The dimension of the volume. As the volume is independent of mass and time, it is said to possess zero dimension in mass, that is m raised to 0, and zero dimension in time t raised to 0, and three dimensions in length L cube within the square bracket. Okay, this is the representation of the volume in terms of the dimensions. Further moving, similarly, force as the product of mass and acceleration can be expressed as force equal to mass into acceleration. The mass can be written as mass only. Acceleration can be written as length per time square. The acceleration is the velocity per unit time or displacement per time square. Okay, the displacement is given in terms of the length and time is time given square of that. Okay, that we can represent in terms of the dimensions. That is, mass is m within the square bracket and length is L within the square bracket. Within the denominator, t square, okay, within the square bracket. This can be written as m raised to 1, L raised to 1, t raised to minus 2. Okay, this is the representation of the force in the form of dimensions. Thus, the force has one dimension in mass and one dimension in length L and minus two dimensions in time, that is a t raised to minus 2. The dimensions in other base quantities are 0. We have not taken other base quantities. Here the three only we have considered. Another four base quantities, what are they? Their dimensions are 0. We are not going to consider. What in the previous slide, m raised to 0, L raised to 0 we have taken. Okay, t raised to 0 what we have taken. Okay, that not necessarily required to mention. Okay, if the power is 1, then only we will consider, otherwise we will leave the what are the actual quantities are there, we are going to represent in terms of the dimension. Note that in this type of representation, the magnitude are not considered. The magnitude we are not going to consider. Only dimensions we are going to consider. It is the quality of the type of physical quantity. It is a quality of type of physical quantity. That is a length, okay, mass, volume, like that. Enters. Thus, a change in velocity, initial velocity, average velocity, final velocity, and speed are all equivalent in this context because all are represented as a displacement per unit time. Here we are not going to take the magnitude of that velocity. Since all these quantities can be expressed as displacement per time or length per time, okay, then that can be in terms of the dimensions. If you write, their dimensions are L within the square bracket, bar or in the denominator t within the square bracket, that can be written as L t raised to minus 1. Remaining part I am going to take in the further sessions. Other sessions links are given in the description. You can refer and watch those also. Thanks for watching. Share, subscribe and comment.